So in this video, what we're going to do is we're going to go through all the exam questions that you guys would have received and that you would have worked through. If not, that's fine. We're going to go through this anyway, and hopefully you can get an idea of what type of questions to expect later on in the year. What I would like you to do is to go through the harder questions that you got wrong and see where you went wrong. So this question here, it's asking us for the correlation coefficient. We've been given the coefficient of determination, which is 0.87329. So that's our R squared value, but what we're trying to find is the R value. To find the R value when we've been given the R squared value, essentially all we're going to do is square root the value, the R squared value. And as you can see at the bottom there, we've square rooted 0.87329. Now you might think that it's 0.934, but what you need to realize is that when we square root a number, we either get a plus or a minus number. Okay, so it's either positive 0.934 or negative 0.934. The way to know which one it is to look at the equation in the least squares regression line, which is negative. The slope is negative 0.327, which indicates, as I'm pointing there, that this slope is a negative slope. Okay, so if our slope's negative, then our R value is also negative. And that's where we got D as our correct answer. Now this one here, okay, there's a couple of ways to do this. The first thing you can recognize is that we have a y-intercept value here that stands out. But before that, we need to recognize what the response variable is or what the explanatory variable is. And that way we can maybe cancel out some options as to ones are correct. So if you look at the options there, we can cross out D because we know that age is not the response variable. So we're down to our final 4 options. Alternatively, after this, what you can do is you can see that our y-intercept is just under 55. But that's where the common mistake happens, okay? Our y-intercept is not actually at 55. The line keeps on going, and that is because the age is not at 0 where it crosses that line. So we need to find what the intercept is when age equals 0. So we know it's well below 55. So what we can do now is cancel out the options in this multiple choice question that have like a 54 as our y-intercept. So we cross out A, we cross out C, and we cross out E, which means B is our correct answer. What I do want to do though is talk to you about how you can do this question when, for example, you might not be given a multiple choice question, but when you have to just work it out. Okay, so what I'd like you guys to do is to open up your calculators. And I want you to find 2 points on this line that you can easily identify. Okay, so the first one I've circled there is when age is 25 and when number of visits is 59. The other one we can see is when age is 35 and when visits is 70. So all I'm going to do is just put that in my calculator and make sure we give it the right titles, age and visits. Then we're going to press Control I, go to Data and Statistics, and put the right variables in. Age is at the bottom, as we can see, and visits on the side. Now we can sort of see that the line's taking form. We just need to create that line. So we're going to create a linear regression. And this here is exactly, if you do it as accurate as possible, is exactly option B, 31.5. And the slope at 1.1. So that's just another way to do it. This question here, you actually need to recognize, so on average, for each additional centimeter in height, the weight is expected to. Now, the hardest thing is to recognize that this is actually asking you for the slope. So this is the answer that when we analyze the slope, that's the type of answer that we see. So how do we work out the slope from these numbers? We need to, and once you recognize that you're trying to find the slope, essentially what you need to do is use these statistics here to help you find the slope value. So what I'm going to do is I'm going to pull up my notes. And as you can see, to find the slope, okay, the slope is what we call the B value, okay? Slope is using this formula here, okay? Using B equals R times the standard deviation of Y divided by the standard deviation of X. So you've got all those numbers here. So all you really need to do, and as you can see here, is we've done R, which is 0.7062 times the standard deviation of Y. Okay, and in this case, we're going to figure out what the Y value is, which is the response variable. Okay, the response variable would be we're going to work out the standard deviation of X. And the standard deviation of X is 7.426. All right, so this would be the the explanatory variable, which is our X, and this is our response variable, which is our Y. Okay, and then we put that over 8.241, okay, which is our response variable, and that's how you get your answer of 0.64. Okay, and you can see the working out in here as well. For this next question, it does take a bit of time, but what you do need to recognize is that you're working out a percentage, all the percentages are here, but you're working out the two-way frequency table. So which one of these tables represents that graphic? Okay, so for under 55 years, we have 35% of people at international. Okay, so under 55, which is this one, all right, for international, we have 49. Okay, so what we're going to do is we're going to work out 49 over 140 and then multiply that by 100 to get the percentage. And if you put that in your calculator, you'll work out that that does indeed equal 35%. Okay, so this one's correct. Then what I want you to do is check all the other four. Okay, so 91 divided by 140 times 100 should get you 65. Now if we scroll back up here, we'll see here that from this point here to this point here is 65. Even though it doesn't actually say it on the sides here, between 35 and 100 is 65%, okay, because that's 65 and that is 35. Okay, so that one is correct. And what you can then do is check this one, and hopefully you'll realize that A is the correct answer. Luckily for you, A is the first one. Okay, if E was the correct one, then you might have to go through all of these and check that they're wrong in order to make sure which one is the correct answer. Just for peace of mind, we're going to check this one here, just to check to see if it's correct or incorrect. All right, so this percentage here should be domestic under 55 should be 65%. Okay, so 65 over 110 times by 100. Let's just see what that is. 65 divided by 110 times by 100. Well, that equals 59. So immediately I know that B is incorrect. And that's what you would have done with the others to figure out that A is the correct answer. For this question here, a lot of you are struggling with significant figures. So all we need to do is round this to 3 significant figures and round this to 3 significant figures. So what we're going to do, I'm just going to do the first one up here. So 0.03931. Underline, all my significant numbers, which is here. Point to the third one and circle the one after. The number that I've circled, which is after that, tells me that we round down, which means we keep the 3 the same. So 0.0393 is 3 significant figures. For the other number, 5.2756, underline all the significant figures, point to the third one. Okay, this number here tells us that we need to round up. So this should be plus 5.28. Okay, it's surprising to see a few of you get this one wrong. Next question says the mean and the standard deviation for each variable are shown in the table below. The equation of the least squares line is this. Use this information to calculate the coefficient of determination as a percentage. So what you'll need to know to do this question is the formula for calculating R, which we looked at before in this video. Now the B value is actually the slope. Okay, so the B value is a slope, which means we put this as our B value. So 5.2756 times the standard deviation of X. Okay, now in this case, the X values are the time 200. So standard deviation is here, 0.96956 over standard deviation of Y, which is 8.2910. You should get an answer of 0.6169, but that's our R value. What we're looking for is the coefficient of determination as a percentage. So to work this out, what we're going to do is square the R value, which is all this squared, put it in your calculator, and you should get, as you can see here, 0.3806. So R squared equals 0.3806. We turn that into a percentage, okay, by multiplying this by 100. Okay, so we can now multiply it by 100 and we get 38.06. So as a percentage, it is 38% if we do it to the nearest whole number, nearest percentage. Okay, so there's a couple of things in here that are a bit tricky. Work out the R formula. That's probably the hardest thing, is to recognize which formula to use. Put in the correct numbers, get the right answer, and don't just stop here. Then we need to square it. So that's how we get the R squared value, but we want it as a percentage. Okay, so this is only for 2 marks. There's a lot of work here for 2 marks. So you need to be very familiar with these formulas. Okay, so the time series plot below shows the winning time in seconds for a 100-meter freestyle swim plot against year. For each year that the Olympics Games were held during this period, a least squared line has been added to the plot. So let's name the explanatory variable. Most of you did well on this. Explanatory variable is the one that's at the bottom. So that would be year. Determine the correlation coefficient. Okay, so again, determine the R value. So to find the correlation coefficient, which is R, we can see in here, it's easy to miss, we can see here that we have the coefficient of determination. So we have the R squared value, which is 0.8794, but what we want is the R value, which is the square root of that number. Which, if you can see from the calculator, it is 0.9377. Now, there's a couple of things here we need to adjust. All right, so let's rub all this out. We know that this is the R value, but we also know, if we look up here, that the data points are going downwards. Okay, so it's really important that you recognize that if the data points are going downwards, then this is going to be a negative R value. Okay, so I'm going to rub all this out. Our R value is going to be negative 0.9377. The other thing you need to look out for is that there's 3 decimal places. So we should eventually realize that, and our final answer will be negative 0.938. This is a question that you'd think it's easy, but there's a lot of things to it. So first thing is actually finding the information here. A lot of people missed it, didn't even see it there. Square rooting it, realizing that it's a negative trend, negative regression line, so we put the negative symbol there, and doing to 3 decimal places. If you don't do any of those 3 things, you don't get any marks. Okay? Just remember, when you square root something, you can either get a positive or a negative answer. Write down the average decrease in winning time in seconds per year during this period. This is another tricky question, but the answer is actually quite simple. Okay? This is another word for slope. Okay, so this question is all about slope. So you need to address where the slope is here. Okay, and recognize that that number there, 0.1515, is the average decrease in winning time in seconds per year. Okay, so 0.1515. Now, another common mistake was to put a negative sign there. But because we've already mentioned the word decrease, we don't actually need to put the negative sign there. If it asked for what is the slope, then yes, you would put the negative 0.1515. But they haven't asked for it here. Here we're asked to find a residual value. Okay, so the predicted winning time for the women's 100-meter freestyle in 2000 was this. The actual winning time was this. So what we need to do is to work out the residual, we need to remember what the formula is. So the residual value equals, and I think it's got the formula here. No, all right. The residual is the actual data value minus the predicted data value. So in this case, the residual equals the actual data value is this much, so 53.83, take away the predicted, which was 54.10, which is negative 0.27. Please don't forget to put that negative sign in there because that is the actual residual value, a negative 0.27. Okay, so then it says, show that the predicted winning time for the women's 100-meter freestyle is this. So I think a lot of you did this well. Most of you got this correct. You just put that into the formula. And if you put that in your calculator, you should get 49.252. What assumption is being made when this equation is being used to predict the winning time for women's 100-meter freestyle? Whenever we predict something, we are assuming the data is linear. Okay, so if we were to do a residual plot on this equation here, okay, we would hopefully see a residual plot with very random and scattered data points. That would allow us to understand whether or not it is linear. Cool. So what we'll need to do is use the two formulas to help us figure out the slope value and then help us figure out the intercept value. So first, let's work out the slope value. Okay, we recognize that this is the formula, r times standard deviation of y divided by standard deviation of x. Put in those numbers there and you should get in your calculator a value of negative 7.15384. Okay, as many decimals as you can for this one. Then using the intercept formula, we put in the correct numbers. So our y bar is 78. Take away our our b value that we just found. So take away a negative number. Make sure you include that in the bracket. And then times it by the x bar value, which is the mean of x. Times it by 5.6, and you should get 118.061. So our closest value to that is, this is what we've got as a whole. Y equals 118.061. Take away 7.15384 times x. So the closest one to that one would most likely be B, this one here. Here we have an association that is non-linear, it's curved. So to linearize it, we need to apply a log transformation. So what you'll need to do is put in this data into your calculator. Make sure you give it the right title so we don't get confused. And then we're going to need to log transform the variable. What does it say here? We need to transform the number of pumps. Okay, so log pumps, and in here we're going to write equals, and then press Control this one to get our log button, and in here put in the 10, and in here put in whatever you called the other one. So we called it pumps. If it goes bold, that's a good thing for us. We press enter and we get all our values. So what we now need to do is we need to press Control I, data and statistics, and then put in the right ones. But now we've got log pumps. So instead of clicking pumps, we're going to click log pumps and then flow. So now that should straighten out the data a little bit, which it has. And we're going to get our regression equation, which is here. So hopefully we see that we get a 5.3 plus 14.05. 5.3 plus 14.05, so it looks like that's the one there. We just need to be careful, though, that we don't select the wrong one. Okay, we know that the flow rate is the one that is on the response variable axis. So flow rate, so our possible options are this one, and this one, and this one. Okay, well, we've been asked to find the log of the pumps. Okay, so that's including pretty much, we're now down, so we've crossed this one out, we've crossed this one out. We're now possible A, possible B, so we're going to cross out D. All right, so we've got, let's just make sure the numbers match now. So we've got 5.3 and 14.05, so our answer should be E. This one here is simply just rounding to significant figures. All right, so here this one should become 42. So let's just write out all the numbers. 42.9842. Let's underline all these numbers that are significant. Point to the third one. Circle the one after. So this number should go up. So we should have 43.0 as our three significant figures. So that means we cross this one out, we cross this one out, and we cross this one out. Now let's do negative 0.877447. All right, so let's underline all the significant figures. Okay, and in this case, all our significant figures are starting from here. Okay, so points to the third significant one, circle the one after, so we should get negative 0.877, in which case E is our correct answer. If you're really, really stuck and you only got one of them and you couldn't round the last one, well, you're down to two options, so that is something you can at least use to your advantage. Here, what we need to do, the first thing is we need to draw the least squares line on the scatter plot above. Now, what I told you guys, most important thing is at least make sure you've got the y-intercept in there. Okay, so as long as it hits 42.1, which should be here, I told you guys in class that you can just, draw a line that goes down, and as long as you hit the y-axis, you're fine. But there's two things. One, that's half of the question answered properly. And two, you're not always going to get a question like this where this is 0 at the bottom. Okay, so what I would suggest that you do always is pull out your calculator and add new calculator, obviously, there. And I want you to just substitute your left value and your right value from the bottom axis. So substitute whatever number's in here. So this one is 0 into the equation. So our equation here is 42.1 take away 1.90 times a sleep time, which is the leftmost number that we've got here, which is 0. Okay, that should get 42.1. That just confirms we were correct. Okay, so put a dot there, and then grab the rightmost number, which is 18, and put it in the same equation. So 42.1, take away 1.9 times 18. Okay, and that should get you 7.9. So here, 7.9 should be about here. And then once you've got those 2 points, you can just connect the line. That would be the best way to always get this question correct. Okay, so just to repeat what I've just done, is I substituted the leftmost value into the equation, and I got this point here, and I substituted the rightmost value into the equation, and I got this point here. That way you'll never get it wrong. In this question here, all they're asking for is to describe this scatter plot in terms of direction and strength. Okay, so direction is definitely negative because it's definitely going downwards. And strength, well, to me, it seems like this is moderate strength. Okay, let's just confirm that that's what they've got. Yeah, moderate and moderate. You only need 2 words for 2 marks. Interpret the slope. Okay, when I see this, I'm really happy because I know how to interpret the slope as long as I can see this equation here. Okay, so the answer is that on average, for every additional hour of sleep, so for every time this goes up by 1, then the response variable, lifespan, decreases by 1.9. Okay, and that's what they've got down here. On average, lifespan decreases by 1.9 years for every additional hour of sleep time. Interpret the coefficient of determination. Okay, so this is part of our lesson structure. We said that once we get the coefficient of determination, okay, which is here, in terms of a percentage. Okay, so the first thing we want to do is 0.416 times 100 should get me 41.6%. So with that percentage, we can say that 41.6% of the variation in lifespan can be explained by the variation in sleep time. Okay, and that's what they've got here. 41.6% of the variation in lifespan can be explained by the variation in sleep time. Last question for this one would be residual. So the lifespan of mammal with a sleep time of 12 hours is 39.2 years. Show that when the least squares line is used to predict, the residual is 19.9. So all we want to do first of all is work out the predicted. Okay, and we already know the actual value. The actual value is 39.2. So the predicted value, okay, is when we say 12 hours, we're going to put 12 hours into our formula. Okay, so up here, 42.1, take away 1.9 times 12. And that should get you an answer of, hopefully it's here, 19.3. So, remember how we said up here that the residual value is the formula, let me find it for you, is the actual data value minus the predicted data value. Okay, so residual is the predicted, the actual, take away the predicted. The actual data value is 39.2 and the predicted value is 19.3. So if we take away these in our calculator, 39.2 take away 19.3, we get 19.9. So you already know the answer, you know what it should be, but we're just asking you to show how they got there. and that's 2 marks. Last question is, what does this residual plot, remember the residual plot is where the line is right through the middle, indicate about the association? Well, because there's no random pattern, that there is a linear association. Because there is no pattern, random points, we assume that there is a linear association.